Hello everyone, welcome back. So in this video we are going to learn about one of the combinational circuit, which is half adder circuit. Okay, so half adder circuit. If you are first time to my channel, please consider subscribing. So half adder is a circuit which adds two input bits. Okay, so this is the functionality of half adder. Since it is having two input bits, so it is having two input bits, I am taking those two input bits as A and B. Okay, so I am assigning the variables A and B to those two input bits, and there will be two outputs. For half adder. I am assigning the name as sum and carry. So I am assigning the name as sum and carry. Okay, so sum and carry. So if you draw the block diagram of half adder, so this is the half adder. So any arrow into the block is called as input. So there are two inputs, there will be two arrows into the block. So A and B are the two arrows into the block, that is inputs, and two arrows out of the block, that is outputs, sum and carry. So these two are inputs and these two are outputs. Okay, so once you got the functionality, so what does it do, and input output variables, that is number of inputs and outputs, and assigning the name variables. Next is to find the truth table. So as I have told you, half adder adds two input bits, that is A plus B. This bit A is called as AND bit, and this bit B is called as AND bit. Okay, so this is called as AND and this is called as AND bit. So I'm writing the truth table now. So what the truth table? First of all, inputs A and B, and then outputs sum and carry. Okay, so these two are inputs and these two are outputs. So A, B, sum and carry. So when there are two inputs, the two input variable combinations we have is 4. 0 0 0 1 1 0 and 1 1. Okay, so when two inputs are 0 0, then the sum is 0 and there will be no carry also. So sum is also 0 and carry is also 0. When you add 0 with 1, sum is 1 and there will be no carry. When you add 1 with 0, the sum is 1 and carry is 0. So 1 plus 1 in decimal, it is 2. So if you convert that into binary, it will be 1 0 base 2. So this 0 will be sum, that is resultant, and this 1 will be propagated as carry. So when you add 1 plus 1, the resultant is 0 and carry is going to be 1. So resultant, that is sum, is 0 and carry is going to be 1. Okay, so this is the truth table of half adder circuit. So next is using K-maps, we have to obtain the simplified output expressions for sum and carry. So first of all, for sum, since there are two input variables A and B, so I am taking a two variable K-map A and B, 0 1 0 1. Okay, so 1, since we are taking SOP expressions only, so where we have to take the combinations where the output is going to be 1, that is we are finding for sum. So sum output 1, for which input combinations we have to represent 1 on the K-map. So 1 is for 0 and 1, so it is 0 and 1. When A is 0 and B is 1, this is the cell. And next 1 and 0, so this is the other cell. Since we cannot group it, so the output of this combination is A bar B, sorry, A into B bar, and the output of this combination is A bar B. So sum is equal to A bar B plus A B bar. That means XOR operation. So we can write it as A XOR with B. So sum is equal to A XOR with B. Similarly, for carry, if you find the K map, or if you draw the K map, so it will be AB 0 1 0 1 here. So there will is only one cell present, so that for that carry for which the input combination is 1 1. So this is the only combination which you have. So we can write it as carry is equal to A into B. So if you design this circuit, we have got sum simplified expression and carry simplified expression. So you can design the circuit now. So A and B are the inputs, and it is given to XOR gate. So A and B are given to XOR gate. You will get the sum, because sum is equal to A in XOR with B. So from this expression we will get this logic diagram. Similarly, carry is equal to A into B, that is an AND gate between the two input variables A and B. So AND gate between those two input variables, sum. So you'll get the carry. Okay, so this is how we can design the half adder circuit. So important thing is, half adder consists of two input and two output variables, and sum is equal to A XOR with B and carry is equal to AB. Okay, so the disadvantage here, the disadvantage of half adder circuit here is in multiple bit addition. Multiple bit addition, it does not take into the carry, it does not consider carry propagated in previous bit addition. It does not consider carry propagated in previous bit addition. So that means suppose, for example, take 1 0 1 0 and you are adding 0 0 1 1. So if you add 0 and 1, you'll get 1. Okay, so 1 plus 1 is 0 and carry is propagated here. So carry is propagated here. So in order to add for this combination, we need 3 input bits. That is carry propagated from previous bit addition and the 2 input bits, 2 actual input bits. So we require 3 bits to perform this addition at this stage. So this is not possible by using half adder circuit. That is what I have told you. So in multiple bit addition, so this is multiple bit addition, so the carry propagated, it does not consider the carry propagated in previous bit addition. So it cannot consider, because there is no availability of third input in the case of half adder. So it does not consider the carry propagated, and the result of this addition will be wrong. So the result of this addition will be wrong. So this is why half adder is not used practically, because in multiple bit addition, it does not consider the carry propagated in previous bit addition. So it is not used practically. Okay, so this is the main disadvantage of half adder circuit. Okay.